Hi everyone, it is April 12th and this is the AWS Nordics Office Hours. My name is Gunnar Grosch and I am a developer advocate here at AWS. And as usual, I'm going to take you through this hour of AWS knowledge sharing. And every week, as usual, I'm joined by a guest. And this week, I am joined by Samane Utter. She is a specialist solutions architect for DynamoDB. Was that right, Samane?
Yeah, that's correct. Hello, everyone.
So this show is all about data modeling for DynamoDB with NoSQL Workbench. And if you have any questions, as usual, just put them in the chat and we'll try to answer those during the session. If we don't get your questions straight away, just take it easy. We're trying to get through all the questions during this hour. So, Samane, tell us a bit about yourself. How long have you been with AWS?
Oh, I have been with AWS a bit more than 2 years. So I can say 2 very interesting years. So I know that it may sound a bit cliche, but I really mean that. So during these 2 years, I had the opportunity to try different roles until I found my passion for DynamoDB and especially for data modeling. So now I feel really privileged to be able to focus on data modeling in my daily work and meet customers from different industries and different use cases, different countries. So to discuss about their data modeling, and hopefully I can help them.
So how did you end up there then? Was it a particular use case that you were working with that got you into DynamoDB?
If I say that because I didn't understand it at the beginning, so I think many people can relate to me. So if you have watched Rick Houlihan's reInvent session from 2018, at least it was for me, I can't remember, 17 or 18. And for me, coming from the relational databases, I felt so uncomfortable, if I'm honest with you, because I thought that's something that is very new for me, and that made me curious. So I was watching his session and also some other sessions in Twitch later on. So I had to pause if it was after, it was a recording. So, and I am lucky that I am married to a software engineer as well. So we were discuss about why did he duplicate this to the other place as well? What happened to all the normalization rules? I mean, so that all made me interested to know more, and as we say in AWS, dive deeper. And then I was lucky to have use cases in real life that I needed to model different databases for customers or the projects that I was working with. So step by step, I built that knowledge. And then I was really, again, lucky to meet Rick Houlihan in one of the customer engagements. And I could see that how during one day he was talking to different customers from different teams from one customer and discussing different use cases. And again, I was really fascinated by data modeling and all those design patterns. So I asked him if it was possible, I joined his meetings. And again, another great thing about working for AWS, it's about shadowing. So you can, if you are brave enough or you're not shy, so reach out to other colleagues that they are more experienced. And basically what I did, and I'm so thankful for that opportunity. And then building this knowledge base and just learning more and more. So that's how I ended up here. Long response to your short question.
Yeah, that's great. So what's so peculiar about data modeling for DynamoDB? How is that different from other type of data modeling, or is it different?
Yeah, it is different because you have to denormalize data. And I think it's not a rocket science, to be honest, as soon as you somehow decode it, you learn the rules of it. or the design patterns, then it's somehow become crystal clear for you. You see the patterns. But I can talk about myself and also some of the customers that I work with. We are so used to the data modeling for relational databases. And by that, I mean the normalization rules. Without even thinking, by default, we have normalization rules in our mind, and to somehow unlearn them and think from a blank page. So that, I think, takes some time, and that's why it becomes sometimes overwhelming for people, because they haven't spent the time to unlearn and get familiar to this new way of thinking. That's my opinion.
Yeah, and as a solutions architect, then, do you often find yourself in those types of situations with customers where you have to make them unlearn and start to think about it in a different way?
Sometimes, I mean, as part of my job and any solution architect, we are the trusted advisor, and part of our work is to challenge them. So I try to challenge them. I have been in a customer meeting that they just show me a JSON payload and say, model it for me. But then I was really pushing back to talk to them through the steps, because as part of my job, it's not just doing the thing. Of course, I am there to support them, but I see my role as a coach, and because they know their use case much, much better than me, and I want to step by step help them through these design steps and also the design patterns that can be applicable for their use case. But we have some customers that I see the design. How I work is that I ask them if they have already they have a data model, so they share the data model. And some customer, they work with NoSQL Workbench and they send the JSON file to me. And I haven't met them. I don't know who they are, but the data model talks to me and tells a lot about in which step they are, how much pre-study they have done, and where I can help them more. So we have different, we have customers with different expertise level, and that's my job to talk to their level and help them to build that knowledge and coach them or point them to the right material that they can build that knowledge base.
Right. So we're going to talk about data modeling for DynamoDB today. So let's get to it then.
Yeah.
Where do we start when we want to do data modeling?
Yeah. It's like there are a few steps. So the first one is you need to understand your use case. So you need to know for what use case you want to design your data. And most of the times that's starts from the business requirements. But it's more important to know that how do you want to retrieve this data? And be specific. So if you are working with APIs, go through the endpoints that you have and see what are the input or what are the values or what are attributes that at the end you need to include into your response. Or if you are working with front end, then what's the data that you are going to populate? For example, last week I was talking to a customer that they wanted to design a data model for a mobile application. Then I was asking, okay, for in each view, what should you fetch from the database? Do you want to fetch everything and cache it into the client side and from there work with the data? Or are you going to are you going to retrieve that data for different view, for different sections from the database and then populate it to your view? So that's also important. The other thing that I ask a customer is about the nature of data. So, and by that I mean, what's the hot part and what's the cold part? What's the part of data that would constantly change? Let's say that the cold part can be my name as a customer name. The name wouldn't change. Yeah, my name changed when I got married, but how often that changed? So that's changeable still, the data, but not as often as if I look at an item that is into my shopping basket. Then the status of that would go from the order to paid to delivered or any other states that we have. Or we have other use cases that maybe the data more often changes. So it's important to know how to group this data. And then later on in the item collection that you are building, then you can separate them. And by item collection, I mean all the items that have the same value as their partition key. So basically, you are creating like a tree. So, and the PK become the top of the tree. And then if you have the sort key, how you are building. And that's the way that you can model one-to-many relationship or collect data that are related to each other into one item collection.
Right.
The other thing is about the nature of your workload. Is it write heavy? Is it read heavy? Because then you should know you should use different design patterns to respond to this nature of workload. For example, if you have a read-heavy workload, then you may need to consider using DAX, which is Data Accelerator. It's a caching that integrates with DynamoDB. Or if you have really write-heavy workload, let's say we had, if all your audience they are in Sweden, so we had, for example, a voting Melody Festival, and let's say that we have few artists that we want to vote to them. So you need to design in a way that they have, they can respond, and they can, how to say it, they can work under several million votes. So,
Yep.
and that doesn't go to the engine. That goes to the design of your data. And disclaimer, I haven't been in contact with Melody Festival and team. I don't know how the data is designed, but that was just an example for the voting and how you want to increase the cardinality of the partition key by using a design pattern. And in this case, it's right sharding design pattern.
Right. So for me, been in software development for quite some time, started off working with relational databases, quite used to being able to just modify the way my tables and my databases looked during development. And what you're talking about now, that is a lot more about doing this before you actually start populating with data, before you start developing that application.
Yeah, that's true. And that's why it's important to take time and really understand your use case, talk to your stakeholders and collect all the data that's necessary. But let's be honest, and there may come a change request after you design your data, and there may be changes during the lifetime of your data model. There are ways that you can work these changes into your data model. I mean, we don't want to design for a flexible data model, but if you have a new access pattern, definitely you can combine that. Or if you want to add new relations, depending on what's that change, there is possibility to change that. It's not that that data model is written on the stone and that can't be changed.
No. All right. So if you just joined us, I am joined today by Samana Utter. We're talking about Amazon DynamoDB data modeling with NoSQL Workbench. And Samana, is it time to perhaps look at an example to show something?
Yeah,
for the audience?
definitely. Because I mean, if you continue with the data modeling that we mentioned, I mean, there are steps that you are preparing, but then how would you start the data modeling? So today I want to walk you through NoSQL Workbench. So it's a tool that I really like using this tool during the design process. So you can see here that you can use this tool for DynamoDB or key spaces, but for today we are going to look into DynamoDB. And if I just walk you through this tool, so if you are new to this tool, so you can download this tool for free from our website. And I can share the link with you. Maybe it was Gunnar, if you are.
Yeah, I can post that in
Yeah,
the
thank
chat.
you. Sorry.
There is a question in the chat in regards to what we just talked about designing. And so do you think about designing for flexibility to be able to change? Or is that something you're thinking about how it might change while you're designing it?
I think it's the second one. So, you know, the whole mindset for when you are designing. I mean, let's look back into NoSQL databases. Why NoSQL databases came into place, and I mean, we don't want to make this session as a history class, but I mean. Let's think about by how many changes we have had during, let's say, by the invent of internet especially. So the volume of data that we have been receiving, and also we are more used to these fast and faster responses. So that's why NoSQL databases came into place, and also by the volume of the requests that each system needs to respond. So in order to respond to the change in the nature of applications, we have NoSQL databases. And if I just look into the DynamoDB, the nature of that is this database is designed to perform consistently, have a high performance, consistent, no matter what scale we are working. And the way that you're designing is that you're optimizing for compute. So if you compare it with relational databases, you are designing because you apply different normalization rules. You want to avoid any data duplication. And if you go to the root of that, that's because the storage has been expensive. So you want to optimize your design for storage. While nowadays the storage is cheap and you want to optimize for compute. And the way that you are working with Dynamo is that you want to design in a way that you want to retrieve the data, because by doing that, you are going to keep consistent performance at any scale that you are. So that's why it's important to know what are the access patterns. Then you are designing for that. You know how you want to retrieve the data, and then you're designing for that. And so that's not the case that, yeah, it is possible to change, so let's go and design a possible queries. No, but we should avoid that. But we know that it's kind of avoidable to have 100% during the lifetime of the application. I hope I responded to that question.
Yeah, I think it was a good response.
Yeah.
All right, so back to NoSQL Workbench. I posted a link in the chat if you want to read more documentation.
Yeah,
so
thank you, Gunnar. And also the link to the download of NoSQL Workbench is available in the documentation as well. So this is a client-based application, and this is available for Linux, Windows, and Mac OS. So after you download the tool, you will see something similar to what I have. I closed this recently edited, so you would see the same sample data models. And If you're new to DynamoDB data modeling, or you would like to dive deeper, I highly encourage you to look into different data models that you see here. So they have different levels, so you can just import them and simply browse through them, or hopefully get inspired from these data models. You can see that you can create new data model, or if you already have one, you can import them. So this tool is basically is built on three sections. So the first one is data modeler. You can see that I have imported a JSON model that I had, or let's say it like this. The data model that you build, it has a JSON format. So the beauty of it is it enables you to work in a collaborative way. So I can sit and design, and then I can simply export that. And you see, you have this export and import options. So you can just share that JSON file. And also this gives you possibility to version control your data model as well. So I have several models here, and let's look into the device state log. In the data modeler section, you can design your table model. You see here, I have designed something really simple, but I just want to walk you through some examples. And if you want to, for example, edit that, you are able to either change the data type, and as you can see for the primary key, so we only can have the attributes that have a scalar data type as a PK. So you have them, or for your non-key attribute, you have all the available data types that you would get from SDK or CLI. So there is no difference in that.
So let's just mention what the primary key is in NoSQL.
Yeah. So let me go back to, I'll gonna respond to your question, but so you see from the data modeler, you can go to, when you're happy with the model of your data, you can go to the visualizer, and let's look into this model. So by the primary key, Gunnar, we have options. Basically, it's how what's happening behind the scene is that when you are adding an item into your table, DynamoDB takes the partition key. So, and if you have been for a while working with DynamoDB, maybe you have heard hash key as well. It's just different name for the same thing. So DynamoDB takes the partition key of the item that you added to your table, and then passes that value to the hash function that DynamoDB has, and create a hash value for it. And then based on that hash value, DynamoDB decides where that item should be stored, so in which partition. And I don't want this session becomes like under the hood, but let's think that if you have your table and from the hash value is from 00 to FF, then DynamoDB, based on either which capacity mode you have decided, let's say partition, if you have decided to go with the provisioned model, or you don't want to even bother with how much capacity you need, you go with the on-demand mode, and you decide to let DynamoDB handles all that capacity management for you. So you are just going to add value, add item, and then DynamoDB decides how many partitions you need. So anyway, it doesn't matter which way you go. DynamoDB decides that how many partitions you have, and by that it divides your table into those partitions, and then say that, let's see, from 00 to FF, if we have 3 partitions, then it finds a logical way and divides that key space. And based on that hash value, your items will be stored in one of those partitions. You see that we have, for the primary key, we have sort key as well. So you may say that I don't need to have any sort key. My value is, let's say, you have just a simple table that you just want to store. Let me show you like this. I have prepared different things for you guys. So let's say that, forget about the rest of this. You just have this item that's about customer. You only have the customer information in that table. And you may ask a question here from me that why did you duplicate the same value for your partition key and sort key in that item? And you're right, I don't need to have a sort key. I only need to have the partition key, because let's say that either this is like a unique ID that I created it with a key, let's say with a UUID or any other ID, unique ID, or there is some other value in my application. But the beauty of using a sort key along with partition key is that it opens up different possibilities for you. And as you can see here, I am able to create, to model the one-to-many relationships between my entities. So that's one way of doing that. And then it sorts, of course, the items that you have for that item key, for that partition key as well.
So in this case, you have a C for a customer, you have a P for products, and so on.
Yeah. And you see that I have an attribute that I call it entity type. And if you have been following DynamoDB data modeling, so you have heard it from my colleagues or other advocates as well. So that's a great way to somehow label your items as well, because you may have a need for that later on. Let's say you want to, if you go back to changing the data model as well, let's say that you want to add a new attribute for product, then you can go through your entire table, and by filter expression, then you can only retrieve the products and add that item, add the new attribute to the item.
Smart. All right, so I got you a bit off track there with partition keys.
No, if there are more questions, that would be good. That's the whole point of this session as well. And I am happy to respond to the questions as much as I can. But if we look into the visualizer, I mean, of course, what we have been doing before this tool or any tool similar to that is you can simply just take a pen and paper and start designing. It's not a rocket science, to be honest. The important thing is all the design patterns that you have. But for me, what I find it really interesting is that, let's say I have a global secondary index. So you know that when you are working with global secondary index, so that's basically the same value that you have it stored in your base table. And then the items get populated to your global secondary index if they have any value for the partition key and sort key of that. What I like it, let's look at this example. So you have your items in your base table, and you can see that then I have a GSI as well. So this GSI, you see how we have created another item collection, and these items, they just get populated into this view. So if you were working with a pen and paper, then you had to do a lot of manual work, or in Excel or anything, any other tool. I like this visualization that you can quickly see that, is this a right way of modeling for my access patterns or not? And if it's okay, I want to walk you through these examples. So let's say that this is about a hypothetical factory, and we have some devices, and each of these devices, they send some status log or a state log. And here I have decided to choose the device ID as my partition key, and that's a value that is has a high cardinality, and that's a good choice for my partition key. Then I decide to use date, the date that this log is received, as my stored key. And I have some states. So let's say that there has been some warning sent, and then it goes to the normal state. I don't want to make this example about the logic of this use case. It's just I want to show you that what would happen. So let's say that for a specific device ID, we want to get all the warning one items. So if by this design, if you want to get the value, then let's see what would happen. I have already committed this data model and the sample data to my AWS account. And you can see another great feature of this tool is that you can commit this either to your tables into AWS account, or you can work it with, let me show you. You can work it with DynamoDB local. And you see that I have already created a connection. So I provided like access key, secret key, and so on. So if I go to operation builder, you see I can go to that connection that I have, and I should see in the region that, because I'm in Sweden, so I chose the Stockholm region, and I have all those tables that I wanted to commit. So here I can interact with my table. So here you see that it's like a scan that happened to my table. And to respond to the query that we have, let me just go here. So I want to perform a query operation in my device state log, and I had this value as my partition key. So I can perform, because I didn't know any specific date, I want to get all the state logs for that partition key, but I was interested in the ones that have state warning 1. So what I'm doing here is that I'm defining a query operation for that specific device ID, and then I want to filter on that based on the status that they have. So if I write it correctly, it should be something like this. And you see that I get 3 items. But what is happening behind the scene? Let me just go back. And by the way, this is the same example in the GitHub that I documented it. So what I want to show you is that I performed the same. This is a good size, Gunnar.
Yeah, that's good.
Yeah. So this is the same query. I highlighted here the same query. It's just by CLI, and what I am done, I'm asking for a specific key condition, and then I ask for this filter expression, and I asked so the same thing basically, as you can see. One thing that's important, and I want to encourage you to start using it, it's those additional parameters that we can provide to the query operation. So here I can use this return consume capacity. And by this, total, so there are different modes. Here I chose total, so it showed me every capacity that was consumed for my table or for indexes as well. So when I perform this query, I would get something like this as a response, as part of my response. And what it tells me, as you see that I have documented as well. So it tells me that for this query, how many items they got scanned. And then from these 4 that were scanned, how many were really returned. So I want to bring your attention to query, and a scan is the same as well. So when you perform the query operation, it has 2 phases. The first phase was about asking for your key condition. So if it's the same here as well. So the first step is this key condition. So depending on you have the partition key and sort key, or you can skip the sort key as we did it here. Then the second step is the filter expression that we had it here. So after you get the first result, so you had this scanned count, then the filter expression will be applied on those 4 items, and then we will get the 3 items as the result. And also, because we chose the parameter return consumed capacity, so we can see that how much capacity we have consumed for these items, for these 4 items. So here it's okay. I mean, it's a normal situation. What if you have like 1,000 items and you are scanning 1,000 items and you only get like 50 items? So you see that ratio is not really smart, and you don't want to pay for the capacity of 1,000 items and then retrieve 50 of that. So what I have done is that, let's go to the visualizer. It's about how you can use design patterns. So there is a design pattern that's called Composite sort key, and I hope the size is, let me just see that. So you can see that I changed my sort key. In the sort key now I have the combination of 2 attributes that I have. What I had before was date, but now I am combining it with the state. So here, what I can do is that I can ask for not only my partition key, but I can ask for a condition on my sort key as well. And the beauty of working with sort key is, let me just show you. So when you have sort key, then you see all the operations that you can apply on your sort key. So what's happening here is that I can use the begins with function, and I can write it this. No, not that one, this one. So I can simply, because now I have the state as part of my sort key, I can skip this filter expression. And you see that I get, again, the same values. But what's happening behind the scene is that you get this result from the first operation. So if I go back, they are the same. Let me find it. So you see here as well, now I have the scanned count and count, they have the same value, because by the operation you had it on sort key, then you could do that filtering without using the filter expression. But this doesn't mean that you should totally avoid the filter expression, because some use cases, they need that. It's just try to design in a way that you can respond to as many queries as possible with your sort keys.
Yeah, so this is going back to what you talked about earlier about the access pattern. Think about the different access patterns you might have. And then, like this, compare the ratio between the scanned count and the actual count. But if it's a pattern that's not commonly used, it might be okay to have a bad ratio if it's just used every now and then.
Exactly. And that can be about the scanning as well, because, you know, I don't want this session becomes like me just talking, because I mean that's really a good now going to the next example, because you know I want to walk you through a GSI, and but before going deeper into that, I just want to just how to say it, double what Gunnar said. While you are thinking about, if you go back to the start of our discussion, that you want to learn about the nature of data, the nature of your workload, you also want to know that how often each of these access patterns you're going to call them, because whatever you, how many GSIs that you are creating, they're going to cost you. You are paying for the storage of that, and of course the IO as well. But so if you have some access patterns that maybe once a while you are calling that, so that's totally fine to use filter expression. Or sometimes you may, depending on your use case as well, you may get everything and then let your application layer do the filtering for you. So it really depends on your use case, but I just want to show you these ways that you can do it. So if you can filter with your design patterns, that's a good way to do it.
We have this banner up now. It depends. That's the
Yeah.
the most common answer on anything we talk about here, but it really does depend.
Yeah, so true.
All right. So if you just joined us now, well, you're 40 minutes late to this awesome discussion on data modeling for Amazon DynamoDB. And Samana is showing us how to use NoSQL Workbench to do this data modeling and to then visualize the data and to also perform operations on the data.
Do we have more questions, or should I go to another example?
No, you must be making total sense for everyone, because there's no questions right now. So yeah. So if you have questions, just post them in the chat. But Samana, please go ahead.
Yeah, another example is, you may criticize me now that where are your access patterns, but I have another example for you. If you want to see that, let me just show you. So if you want to see how from the start of working on a use case, this is a very simplified, like a hello world example, but that walks you through a step-by-step of the things that are covered from the beginning. So get to know your use case, what's the relation between your entities, and then from the access pattern that you have collected from the different stakeholders, then how you are going to design for them. So I highly encourage you to especially if you're new to designing for DynamoDB, you go through this example, because I show you how a step-by-step respond to each access pattern. And you see, it's like those cooking program in TV. So I have created these different JSONs, so you can import them step-by-step to your NoSQL Workbench and see that how that data model evolves when you are going through different access patterns. And you see here as well how to document those access patterns. But today I don't want to cover that. So
this is a great example, because this talks about relational data, and that is quite common in a lot of the things we build.
Yeah, definitely. So if you want to see how from the start to end I build this data model, because from the start it's not so visible for you that how you should, what you should choose for your partition key or sort key, or do you need any indexes or not. So you can follow this example. But I want to walk you through this example now. The device state log, as I said, this also is available in the same GitHub repository. Let's see that here we have, now we optimized our sort key. So we use the composite sort key. But let's say that we want to get another view from this existing data in our table. You see that I have operator attributes. So let's say that when there is when a device sends a state log, then that should get assigned to an operator, because maybe they should go to check on them or for any reason. So let's say that we want to know what are the logs that are assigned to Liz, in this case, this operator. You see that by the design that we have now, we cannot, without knowing the device ID, we cannot get that value. So there should be a way that if you want to specifically for asking for, let's say that Liz wants to know what are the logs that are assigned to her. So by using a global secondary index, you can get another view on the data that exists on your table. So if I just show you how that's created, you see that, let's see, in which one is it? Is it in the, no, it's in this one. So if you see with a NoSQL Workbench, you can also create a global secondary index. So here we have the table, partition key, and the attributes that we have. And then we have the global secondary index. And in this case, I have 2. And then you decide which attribute from your base table is going to be the partition key and the sort key for your global secondary index. So that's how I defined that. And if I go to the visualizer part, you see that that's how we can get another view over the existing items that are stored in the base table. And in this example, I chose basically because I want to get all the items that's in my, let's see here, all the items that are here, all the logs, they are assigned, they have an operator. So I want all of these items get populated to my GSI. That's why I chose operator, and because all of these items, they have this value, they will get populated here. And then you can see that I chose date as my sort key here. So we have created another view of the same data that we have into our table. So if you want to ask for any log that's assigned to Liz, let's see actually how we can do that. This time I want to show you particle as well. So I don't know if you have been following news on DynamoDB, but I think it was around reInvent 2020 that you can run particle as well. So if you are more in favor of SQL commands, so you can use particle, which is a SQL compatible query language. So let's say that select from, which table was it? I think it was device state log, or let's just say,
I think it was device state log _7.
Yeah. I think so. So device state log 7, then you can basically get everything that you have, and then you can also perform, you can get from the other view as well for it. So this is how you can get another view of your table and index. But what if you have a scenario that, let's say, you want to find a needle in the haystack? So if you are familiar with GSI nature, then you know that what I'm going to talk about. So what I like about the GSI is that it has a sparse nature. And by that, what I mean is, let's look into this model as well. It's the same model, so we still have the operator, But let's say that some items, some of the logs, they need to get escalated. And you see, not all the logs, they have that need, but just one of them they need. And in this case, we have this specific log, let's say that with warning for, or whatever the use case or the logic is behind that, then in your application layer, it decides that this log, either it should get updated, or even from the time that you're writing it, then you are escalating that. So now we have this attribute, and you see I have another GSI that I chose escalated to as the partition key. And then for the sort key, I have the same sort key as I had it for my base table. So because escalator 2 is the partition key, only this item will get populated into this GSI2. So if you are familiar, if you are new to GSI, just please notice this, that you never write to GSI directly, or even your LSI. What's happening is that behind the scene, with the attribute that you decided, you specify it as the primary key of your index, then for the items that they have that value, DynamoDB recognizes them and then populate them as part of your index. And this is a great way to, because as you see, we have filtered all other items, and now we only have them, that's one item that's really got escalated. So let's say that you have many other logs that are escalated, and in this case, you can simply, if you need to, you can run a scan operation, because you have already filtered everything else that you didn't need. So it's not going to be as costly as if you would run the scan on your base table, because then you would go through the entire table. While going through this GSI, you only removed everything else that shouldn't be here.
That's really great. So, and as you said, the needle in the haystack.
Yeah.
Well, when you need the needle in the haystack, that's really good. And you talked briefly about GSIs, that you shouldn't overuse them because of costs. And I suppose in this case, the cost will only occur when either if you have provisioned concurrence or provisioned
capacity.
I lost the name. Capacity for that GSI, and then for the storage of those items.
Exactly. If you go with the on-demand, then you just pay for how much you are interacting with your GSI. And I mean, if let's say that it's not about escalation, let's say it's about any other use case, and you only need to retrieve this every quarter, then go ahead and run the scan. Because again, it depends. So it should make sense. And I mean, you can just simply do like a on the napkin calculation and see that does it make sense to go with this way or to the other way, and how fast do you need to have the value. Because if you want to have something, let's say here escalation, you want to see it as quickly as possible, and maybe you come to this view several times per day. If you are a supervisor, then you definitely want to have a GSI for this use case.
Yeah. So once again, back to thinking about those access patterns and how often they're used, if they are frequent.
I just want to, I see that we have few minutes left. If you don't have more question for me, Gunnar.
No, go ahead.
I mean, what I showed you before was that for a specific for a specific use case, and then you saw that in the entire table, I had the device state logs. So for that use case, if I just quickly go back, you see that for this use case, it makes sense to have a device ID or date here because I only have the device ID. But if I walk you through this online shop, because here you can see that I chose a more generic name for my partition key and sort key. So I don't say that this is a customer ID or product ID or whatever entity that I store here, because in this example I am using overloading design pattern. So basically I overload my base table with different entity types. If you are following Rick Houlihan's work or if you have been following DynamoDB work, so you know you may heard a single table design or polymorphic tables. So what is happening is that instead of just having a customer table or product table, now I have collected them into one single table. And that's why I choose a generic name. Another thing, as I said earlier, was having an attribute that I basically mark every item as what's the entity type. Also, you can see that I choose for the IDs that I have. I mean, I do appreciate that this is a very simplified ID, but if you have any other ID that's applicable for your application, in order to make sure that these are definitely unique, so you can identify them, use this prefix, let's say that for customers C, and then any delimiter that you would like to use. And then this is a great way to basically collect all the data that's related to each other into one place. And of course, you should be respectful of the domain of microservices. For example, if you're working, so you want to just collect the items that are in that microservices. But the beauty of it is, you see, how, for example, if I want to collect the products that I have, so I want to see in which warehouses they are available. So I don't need to go to another table, which is a warehouse table, and then collect that. So I can build that relation in this table. But as I said, everything is available in this example. I have documented step by step, so you can follow that if you are interested in.
Yes, I'll share the links once again. So Samana, with that, I think it's time to do a bit of a wrap up. So let's just take the basic things. What are the most important things, once again, when you want to start modeling your data?
Your access patterns.
Yes. All right. So think about the access patterns, and well, how you do that, that's up to you, but you can just try to get them on paper or in an Excel sheet, or with the help of SQL Workbench, of course, as well, to start modeling the data there and looking at the different access patterns. So in the meantime, then, if you want to see more of Samana this week, I think there is a way of doing that, isn't it, Samana?
Yeah. If you are not tired of me and listening to me talking about DynamoDB, so you can follow me in the AWS Dev Day. So you can, I'll cover more example, and also I will use the NoSQL Workbench with and show how you can generate code with NoSQL Workbench as well, and simply use that in your POC or start working with it. So.
And of course, you can get in touch with both of us on Twitter as well. If you have any questions, we're running out of time here. I'm just going to try to get those links in the chat once more for both the, let's see, the different DynamoDB design patterns that you showed us. Getting them there. And yeah, with that, I think it's a wrap. Thank you very much, Samana, for joining us today. And thank you everyone for watching. So this has been an episode of AWS Nordics Office Hours. Samana has talked about DynamoDB and designing for DynamoDB using NoSQL Workbench. Sorry. All right. Have a good day ahead, everyone. And hopefully I'll see you next week.
Bye.
Bye-bye.